everyone, or good afternoon whenever you're doing this. Let's begin today by having a look at the mental starter, just a reminder of how to find equivalent fractions. So if we just have a look over here, I've done a demonstration of fifths, finding equivalent fraction of fifths. So we've got 2 fifths is equal to 4 tenths. Now if you look at either the numerator, the top number, or the denominator, the bottom number, you'll spot a pattern. So this one goes 2, 4, something, 8, 10, 12. So if we think about our times tables, it's 2, 4, 6, 8, 10, 12. So you know that 6 fifteenths is now equivalent to 4 tenths, which is equivalent to 2 fifths. And you do exactly the same thing with the denominator, but it will be at different times tables. So this time it's 5 times tables. So this is going 5, 10, 15. So the next number would be 20. The next one, 25. And the last one, 30. Just in case you don't believe me, I've drawn fifths here. So if I shade in 2 fifths, just to demonstrate, so we've got 1 fifth, fifths because it's 5 equal parts, 2 fifths, and then if I was to take those 2 fifths and split them into tenths, can you see that 1, 2, 3, 4 tenths is exactly the same as 1, 2 fifths. And if I continue to do that, these would all be equivalent. Now what you've also done with equivalent fractions is to simplify. So if we come right to the end and we look at this one and we ask ourselves which number can we divide both the top and the bottom by, we can divide this one by 6 and that gives us the answer 2 if I write it under here. That's the numerator. If we do the denominator by 6, so if we divide that by 6, we get 5, and you can see that is the same fraction that we began with. So that is how you would approach that mental starter. Okay, so that was just a warm-up for today. What we're actually going to be doing for the rest of the week is looking at moving digits in order to convert measures. So let's just have a look at the first slide. Okay, so on Monday, today, the first day, we are going to practice moving digits in order to multiply by 10 or 100 or 1,000. Now, when you multiply anything by 1, the number always stays the same. So for example, if I use this board, 21 times 1, the answer will be 21. Always stays the same. If you multiply that number, the same number, by 10, there is 1 0. That means that we use 21 and we take the number and we move to multiply, we move the digits left because it's getting bigger. If I demonstrate here, we've got 21 is 2 tens, 1 unit. We want to move those digits one place to the left. There's 1 0. So that 2 then moves into the hundreds column. The 1 then moves into the tens column. And the decimal point always stays in the same place. Now that leaves us with an empty gap. And you know from before that whenever we do that and we produce an empty gap, we use the 0 placeholder. So 21 times 10 is 210. Now similarly, if it's 21 times 100, there are 2 zeros, so we move 21 2 places to the left. So in this case, excuse me doing this, in this case we count 1, 2, so that 2 ends up there, 1, 2, the 1 ends up here. And because we've got the zeros, the decimal point always has to stay in the same place. We've got empty spaces, so we need to put in 0 as a placeholder. And we put in 2 zeros because we are multiplying by 100 and there are 2 zeros in 100. So 21 times 10 would be 2,100. And we can keep going like that. 21 times 1,000. 1,000 has 3 zeros. We end up moving 21, 1, 2, 3 places to the left. So 21 goes there, 2,100, and we put in the zeros, 21,000, 21, and we have 3 zeros because we were multiplying by 1,000. So that's the technique that you're going to use today. What I would suggest, if you were in school, you would use a whiteboard and you would draw one of these grids. What I would suggest is that you have one of these handy, and you always start off, make sure the decimal point does not move. The decimal point always stays in the same place, always. No matter what you're doing, it never moves. And then maybe just use scrap paper if you're at home and just write in the number and count the number of spaces and draw it in underneath, and then put in the zero placeholders, whatever you're doing. Now that's to multiply your moving digits to the left. You do exactly the same thing to divide, only this time when you're dividing and you're sharing out, the number is getting smaller. So because the number is getting smaller, you're moving this time to the right. So let's do the same thing. And make sure the decimal point always stays the same. Let's do 21 again, and this time we are dividing by 10. So we start off with 21. Because we are dividing by 10, we always move to the right. So this time, the 2 moves into the ones column. This 1 moves into the tenths column after the decimal point. So 21 divided by 10 would give you the answer 2.1. Similarly, just like we did before, 21 divided by 100, you've got 2 zeros, so you would move 21 2 places. So we would count 1, 2, 2 goes there, 1, 2, the 1 goes into the hundreds column. This time, we've got 0.21 after the decimal point, so we need to remember to put the placeholder where there is no gap in the zeros column, so the answer would be 0.21. Exactly the same principle if you're multiplying by 1,000, 3 zeros, so you move 3 places to the right. So you would end up with 0.021. 0.021, and so on. Now we've done this before, that's just a reminder really of how to do it. Let's just quickly have a look at the next slide. Right, so the work that you're going to be doing today is either simply multiplying or dividing by 10. If you want some practice, you start with the mild one. That's what we've just done there, and you simply write the answers. If you want a bit of a challenge, it mixes up division and multiplication, and make sure you're looking at the number of zeros, if it's 1 0, 2 0 or 3 zeros, to know how many places you're moving. And if you'd like a challenge, you can do the spicy one, which means you've got a missing number. Now let's just have a look here. So if it was something times 10 is 600,000. What do we do in that case? To work out the missing number, you always use the inverse. So the inverse of multiplication is division. So in order to work this out, you would take 600,000 and you divide it by 10. And because you're dividing by 10, let me just rub this out. Because you're dividing by 10, the number is going to get smaller. So you go to the right. Remember, to divide, you move the digits right. You would put 600,000 in. So I'm going to go backwards here. And we need a 6 in this column. 600,000. Because you've got 1 0 and you're dividing by 1 0, you're moving everything 1 place to the right. So the 6 moves 1 place, the 0 moves 1 place, and so on, and you end up with everything having moved. So your answer your answer would be 60,000. Okay, so when it's a missing number, you need to use the inverse. So if you have a look, if it's something times 10, to find the answer, you do the answer divided by 10. If it's something divided by 10, to get the answer, you would take the final sum, the solution, and you would multiply by 10. And you always use the same principle, moving the digits. If you're multiplying, you move left. If you're dividing, you move right. Enjoy this challenge today. If you are finished and you want an extra challenge, there are some mastery sheets. I won't go through those. I'll let you have a read at those. And as usual, all the answers are at the end of this PowerPoint, at the end of this screen. At the end of the screens, you can have a look and see. Just make sure when you're looking at them that you read the questions carefully. If it says something like find 3 possible solutions, make sure you give 3 answers and not just 1. Enjoy this today, and tomorrow and the rest of the week we will be using the same principle and applying it to converting measures. Enjoy. We're finished for today.